Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is example 35 on the applications of the dot product. Forces F1 and F2 are concurrent at ring A, and it is desired to determine the component R sub n of the resultant in the direction of the unit vector lambda sub n when theta is 45 degrees, 40 degrees. Evaluate this component according to this definition. R sub n equals quantity F1 plus F2, the resultant of F1 and F2, then dotted with the unit vector n. Then letter B, other definition, Rn is the dot product of the first force with lambda n plus the dot product of the second force with lambda n. And here is the figure. So for the first definition, let's find the resultant of the two by expressing its force into vector form. Anyway, these are just 2D. So F1 in vector form is 2000 quantity cosine of 50 degrees I plus sine 50 degrees J. So simplifying, F1 is 1285.575 I plus 1532.089 J newtons. F2, the angle that F2 makes with the positive x-axis is 160 degrees or 180 minus 20, so that's 160 degrees. So F2 is 3000 times quantity cosine of 160 degrees I plus sine 160 degrees J. Then expressing in decimal, F2 is negative 2819.079 I plus 1026.060 J newtons. Then the resultant is simply sum in vector form, sum of corresponding components. So F1 plus F2 is 1285.575 minus 2819.079 I. Then, lambda n is cosine of negative 40 because theta is 40 degrees and it is clockwise, so the angle is treated negative 40. Or the other way, if you make this positive, cosine of 320 degrees, 360 minus 40 is 320 degrees. You can change negative 40 degrees to 320 degrees. Anyway, they are the same. So F1 plus lambda n in same expression, so it's the same. Then F1 plus F2 is negative 1533.504 I plus 2558.149 J. After adding 1285.575 and negative 2819.079. Then after adding 1532.089 and 1026.06. So that's the resultant. Then applying this definition by that product, Rn equals negative 1533.504 I plus 2558.149 J times cosine negative 40 degrees I plus sine negative 40 degrees J. Then the Rn is negative 1533.504 times cosine of negative 40 plus 2558.149 times sine of negative 40. J dot J is 1, I dot I is 1, remember. So R sub n is equal to negative 2819 newtons. So that's the answer. For part B, Rn equals F1 1285.575 I plus 1532.089 J dot cosine of negative 40 degrees I plus sine negative 40 degrees J. And the expansion is same, 1285.575 times cosine negative 40, by the way, plus F2, this is F2, that cosine of negative 40 degrees I plus sine negative 40 degrees J. So 1285.575 times cosine negative 40, I dot I is 1, so that's 94.808. 1532.089 times sine negative 40, that's negative 984.808. Negative 2819.079 times cosine negative 40, that's negative 2159.54. Then plus 1026.06 times sine negative 40, that's negative 659.539. Combining, that's, we can cancel this, so negative 2819 newtons. So for your part, the resultant of the forces F1 and F2 is known to have a component 500 newtons in the direction of the unit vector lambda n. So Rn is positive 500 newtons. So determine the corresponding angle theta. So show that this is the answer. Theta is 40.59 degrees counterclockwise from the horizontal, meaning to say theta is above the horizontal. Not this one, but here. It's close to the force F1. And it is shown here. So that's your part.